Okay, today we're going to work with radical expressions and how to simplify them. So a radical expression is anything with the square root sign. And if you notice this one particular square root sign has a 3 in a 3 there. That's interesting. Actually, you could have any number there. It could be 4, it could be 5, it could be 6. The one you're used to working with is square root, and the 2 there is understood, so we don't write it, right? So anyway, an expression such as the square root, this in particular is a cube root. The number or expression under the radical sign is called the radicand, and in this case it's this. An entire radical is of this form, whereas a mixed radical, you would express it in this form. So as soon as you simplify a radical and get out any perfect squares, it becomes a mixed radical. So there's some rules that I want to see on your study notes when you finally do make them. That's this and this. Okay? So what do these rules tell us? Multiplying radical expressions. Just notice that square root of 4 times square root of 5. Well, you know the root of 4 is 2. The root of 25 is 5. 2 times 5 is 10. Okay? Or you could multiply inside the radical sign and you would get 4 times 25 is 100. Notice you get the same result. They're both 10. Do you see the difference between the two? Here we took the square roots first, then we multiplied. Here we multiplied 4 times 25 and took the square root at the end. So there's the rule there. This applies to division as well. I'm just going to work this one out for you. Do you agree that when it's a third root or a cube root, we're looking for a number multiplied by itself 3 times gives us 27, and a number multiplied by itself 3 times gives us 8? Well, as a result, it's 3 multiplied by itself 3 times gives us 27, and 2 multiplied by itself 3 times gives us 8. So that's the type of answer it's looking for. But to illustrate this rule, you could either work it out like this, where you take the cube root of 27 is 3 and the cube root of 8 is 2, or you can work on it together, or you can split it up like that and you get the same answer. Okay? So the nth root of a divided by a is equal to the nth root of a divided by the nth root of b. No, nth root of a divided by b equals that, okay? So when we simplify, what we are doing is we are going to factor the radicand, and we're going to remove any perfect squares. Perfect squares are like 4, 9, 16, 25. 6 times 6 is 36. 7 times 7, 49, etc., etc. So when we simplify this, we write it as a product. You agree the biggest perfect square is 4. So we could take the square root of 4 and write it like this. Can I answer any questions on this? Do you see how we're simplifying and we're trying to make that number inside the radical sign as small as possible, and we do that by removing any perfect square roots. So for example, square root of 32 is the same as 16 times 2. Well, the square root of 16 is 4, and there we have it, right? So this is simplified now. Similarly here, what do you think is the biggest perfect square in 72? 36. Good. Are we good? Okay. Let's keep going. We have a bit of work to do here. Well, we're dividing. We might as well just treat it like this. 40 divided by 5. That's just the root of 8. Am I done? Is that fully simplified? No, we have to take it to root 4 times 2, and we have to take out any perfect square factors. Square root of 4 is 2, 2. Here we can do the same thing. We can just, this is the same as 12 over 4, root 75 over 3. This is an extra step you don't have to write on the test, but this is the same as 3 root 25. You know the square root of 25 is 5, so we go 5 times 3 is 15. Okay, so this is the same as 2 over 1 basically times root 2 over 18. Oh. So we've got 2 times root 1 over 9. Well, what's the square root of 1 over 9? It's 1 over 3. And that is equal to 2 over 3. So let's keep going. So you multiply what's outside the radical sign. 2 times 3 is 6. Multiply what's inside. That equals 6 times square root of 25 times 2. Well, square root of 25 is 5. 5 times 6 is 30 root 2. Well, let's see what we can do here. This is, well, let's see. This is 12 minus 9 times 3 over 3. And that is equal to 12 minus 3 root 3 over 3. Because we can take the square root of 9. Are we done? So let's factor out a 3 out of the numerator. 4 minus root 3 over 3. That divides out, and we're at 4 minus root 3. I want to point out to you a very common mistake that a lot of people were making on the test. A lot of people did, when they got to something like this that was similar to this, they went and then they said that would equal. Do you see how you can't divide out across a minus sign? You have to factor first because the brackets here are understood. Here we factored out a 3. That has to stay together, but we could divide out the 3 here, okay? It's important. To simplify radical expressions, make sure there's no perfect squares other than 1. The radicand does not contain a fraction, and no radical appears in the denominator. So let's see. I will demonstrate this on the next page when we rationalize the denominator. Let's add and subtract. Again, you're adding and subtracting like terms. 5 root 3 minus 2 root 3 is 3 root 3. Negative 2 root 6 plus 6 root 6 is plus 4 root 6. We can't add these together because they're not like terms. You can't add a root 3 to a root 6. Let's see what this guy does. Well, that's 4 times 28 is 4 root 7. 63 is 9 times 7. So now we have square root of 4 is 2, so we can bring that out. Square root of 9 is 3, so we can bring that out. Ooh, we have 2 like terms, and this is equal to 5 root 7. To multiply radical expressions, note that, well, we just did that, a root b times c root d, you multiply the numbers outside, and then you multiply the numbers inside the radical sign. So let's do this. Root 5 times root 10 is root 50. Root 5 times minus 1 is minus root 5. This is the same as 25 times 2 minus root 5. The square root of 25 is 5. Now we're done. This is the final answer. You're not done until you've simplified the radical sign. Yes. Oh, you're right. I did. Thank you for pointing that out. Appreciate it. Okay, let's do this one. Again, take out any perfect squares. So negative 2, 4 times 5, plus 4, 25 times 5, minus 3, 100 times 5, plus root 9 times 5. So let's bring out those perfect squares. Square root of 4 is 2. That's going to be negative 4 root 5. Square root of 25 is 5. That's going to be 20 root 5. Square root of 100 is 10. That's minus 30 root 5. Square root of 9 is 3 root 5. Okay, that's positive 16 minus 14 plus 3 is minus 11 root 5. May I explain anything better? Any questions? Okay, we're going to go this times this times this, inner, outer. 3 root, so we're going to multiply 3 times 5 is 15. That's root 7 times 7 is 49. A positive times a negative is a negative. 3 times 4 is 12. 7 times 5 is 35. 2 times 5 is 10. 5 times 7 is 35. Now we go negative 2 times negative 4 is positive 8. And root 5 times root 5 is root 25. So we have 15 times 7 minus 22 root 35 plus 8 times 5. This is going to be 7 times 5 is 35. That's 105 minus 22 root 35 plus 8 times 5 is 40. So this is 147. Do you feel I'm going too fast? Yeah? Okay, I'll... Oh, you're absolutely right. Thank you. May I elaborate on anything? Yes.
I don't know how you got to the second step.
Here,
15 times 7, yeah.
square root of 49 is 7. And then square root of 25 is 5. And then I added these together. Negative 12 root, that's negative 22 root 35. This one here? Do you want the second line? Okay. Do you let me see, I'll just get some paper to put underneath it. Do you agree that root 49 is 7? And that's minus 12 root 35 minus 10 root 35. And the square root of 25 is 5. So that's 105 minus 22 root 35 plus 40. And that's 145 minus 22 root 35. Good? Is it okay? Rationalize the denominator. Well, when we rationalize the denominator, we want to get rid of the radical out of the denominator. So we basically multiply by 1, and when we multiply, we hope things cancel out. So for example, the more correct terminology is, this is an irrational number. We want the denominator to be rational. So what we do is, we multiply by 1, so we're going to multiply by root 3 so that that radical sign disappears. I'm multiplying by 1, I'm not changing anything. Root 3 divided by root 3 is 1. So this is going to be 3 root 6 over 2 root 9, and that's going to be 3 root 6 over 2 times 3. And the 3 will divide out, and that equals root 6 over 2. Okay, what do you think I multiply this by? B. What should I multiply B by? Root 6 divided by root 6, right? Okay, so that's going to be 5 root 6 over 4 root 36. That's 5 root 6 over 4 times 6. And this is 5 root 6 over 24. Good? Now, it gets trickier when your denominator is a binomial with the radical. So what we're going to do is we're going to multiply it by the conjugate. The conjugate is, notice, these are conjugates of each other. They're identical except one is a positive and one is a negative. Okay, so what do you think the conjugate in this case is? Right, 6 minus, thank you very much. 6 minus root 2. Okay, so this is 6 minus root 2 all over. Now we FOIL. 6 times 6 is 36 minus 6 root 2 plus 6 root 2 minus root 4. Right, I just FOIL. 6 times 6 is 36. 6 times root 2 is 6 root 2. 6 times root 2 is 6 root 2. Well, one's a minus, one's a plus. Root 2 times root 2 is root 4. So now we have 6 minus root 2 over 36 minus 2. Right, because negative 6 root 2 plus 6 root 2 is 0. So this equals 6 minus root 2 over 34. What's the conjugate of this number? Two root 5 plus 4. 2 root 5 plus 4. Right? They're identical except they have a different sign on the second term. Now we FOIL. This is 2 root 25 plus 4 root 5 plus 6 root 5 plus 12 all over 4 root 25 plus 8 root 5 minus 8 root 5 minus 16. It's just a bunch of tedious calculations. So this is going to be 2 times root 25. 2 times 5 is 10. This is 10 root 5 plus 12. 4 times 5 is 20. Plus 8 root 5 minus 8 root 5 is 0, so it's minus 16. 22 plus 10 root 5 over 4. Are we done? We can reduce to lowest terms. I'll factor out a 2. And that equals 11 plus 5 root 5 over 2. Right? Be very careful. Don't just go 4 divided by... I'm sorry. Can I explain anything better?
In the last question for A, why didn't you reduce the 6 and the 34? Take out 2 or something.
Where's that?
That?
4a?
Yeah, yeah. Can you divide the top and bottom by 2?
By 2?
Yeah.
No. You're dividing across the minus sign. If you do this, now if you do this, you would get, that's not this and this are not equivalent. We can't do anything there. If we could factor out a 2 from both, yes, but that's root 2. It's not a factor of 2. It's not 2, it's root 2. It's different. It's square root of 2. Okay, now they give us the answers. Let's now get the quadratic expression. So let's just work backwards. They give us the answer x equals 4 plus root 3 and x equals 4 minus root 3. So when we solve a quadratic expression, these are equated to 0 to solve, right? Now these are our two factors that we can use to find the quadratic equation. So we're just working backwards from factoring. Now they want that equation in this form, so we're going to FOIL. X times x is x squared. X times negative 4 is negative 4x. X times 3 is root 3x. Negative 4 times x is negative 4x. That's going to be positive 16. And that's negative 4 root 3. This is going to be minus root 3x. Then plus 4 root 3, and this is going to be plus root 9 equals 0. We're just foiling. That times that is that. That times that. There's 9 multiplications here, because there's a trinomial times a trinomial. So notice 4 root 3 minus 4 root 3, root 3x minus root 3x. So now we have x squared minus 4x. That minus 4 plus 16 is 12. 12 plus 3 is 15. No. 12. That's 12. Plus 3 is 15. I think I'm just going to double check my work. I think I made a boo-boo.
Okay.
That should be an x, right? Yeah.
For the square root of 3x that you cross out, how is it positive? Because isn't it negative?
This is negative. Do you agree this is negative root 3x?
No, the first one.
The first one is x times positive root 3. And this one is negative root 3 times. So that one is negative. So I missed an x there because negative 4 times x is negative 4x, so that's negative 8x. And here we have 16, and this should be negative. Uh-oh. Sorry, guys. A negative times a positive is a negative, so that's minus 3, so it's plus 13 equals 0. So my original solution, I forgot an x, and that here I dropped it. That should have been a negative. Can I explain anything better?
Can you repeat the last part?
This one? To go from the... Okay, so that's positive root 3x, that's negative root 3x, so that equals, those two cancel out, they equal 0. And this one's negative 4 root 3, and this one's positive 4 root 3, so they cancel out. And then you have x squared. There's 2 minus 4x's, which equal negative 8x. 16 minus root 9 is 16 minus 3 is 13.
Oh, so that's a negative.
There should be a negative. That was my mistake earlier. Are we good? Okay, what were the homework questions? Can I know the homework questions? Let's take those up. You had a homework? Somebody had a, yep. Number 15, absolutely. Oh, it's page 32, right? Number 15. Here we go. Here's number 15. And here's the paper I'm going to use. All right, number 15 says h of t equals negative 1/2 g t squared plus vt. What's the coefficient in front of t squared? Is it negative 1/2 or negative 1/2 g? Yeah, okay. See, because they want you, first we have to find the vertex, then we can answer A and B. So h of t equals negative 1/2 g of t squared minus, well, let's see, 2v over g t. What? Huh? Oh, you want another bracket?
Wait, why is it 2b over 2?
Okay, so what we're doing is we're going v divided by negative 1/2. Well, we're dividing by negative g over 2. Do you agree that this is basically negative g over 2? So this is v divided by negative g over 2 multiplied by the reciprocal. Oh, I'm sorry. Right, we're dividing, basically in order to find out what to write here, I go v divided by negative 1/2 g, which is negative g over 2, multiplied by the reciprocal, and that equals negative 2v over g. Whenever you divide by a fraction, you multiply by the reciprocal. Okay, so now negative 1/2 g t squared minus 2v over gt. We have to complete the square. So we have and square the coefficient of the linear term. So that divides out, so that's v squared over g squared. So we add v squared over g squared, and we subtract v squared over g squared. See, I halved and squared the coefficient of the middle term. Okay, let's kick this guy out. This square root of the first term is t. Square root of this term here is v over g. We kick this guy out and we have negative 1/2 g times v squared over g squared.
Isn't t minus v over t squared?
Sorry?
No, for the one, yeah, no.
Thank you. I'm getting tired. Okay, so we have negative 1/2 g t minus v over g all squared. So 1g cancels out. So this is going to be positive v squared over 2g. So it's max. This is a negative. We know it opens down. The vertex is a max. So the max is v squared over 2g. The min is, and it occurs, if there's a max, there's no min. It occurs when t equals v over g.
Is that gonna be our test?
Could be. Does it make sense now? Is it better now? Are you sure? Do you want me to do it again?
I didn't even know you could multiply them.
You didn't know you can multiply what?
At the end, like I thought he was just adding and subtracting. Like out of the bracket.
Oh, this.
Yeah.
Well, there was nothing else. Oh, it's just this times this. Any other questions?
14.
14? Huh? I still want to give you your test back. I'll do this off the record button, okay?